Question 3 we did in class yesterday, and I need you to use your calculator to sketch the graph of this. So this is going to be 500 divided by parentheses 1 plus e to the 3.9 minus 0.4 x. Okay, close parentheses. Now, when I go to graph this, I'm basically not going to see anything. So we need to do a little thinking ahead of time. What I know is that as far as our t value is concerned, t is the number of years since 1990. I don't really care what happened prior to 1990. So for t, I'm going to let t be in the interval from 0 to, I don't know, arbitrarily 50. So that's my x min, x max. As far as my y values are concerned, well, what I can do is I can figure out what my y value is at 0. So again, that's my y vars thing. So at 0, I get 9.9. So I know my y-intercept is 9.9. And I'd like to know what happens as time wears on. So what I'm going to do is not bother playing around with my calculator. What I'm going to do is look at what's happening at this end of the graph. In other words, I'm going to take the limit as x approaches infinity and just see what happens. So we're going to have 500 over 1 plus e to the 3.9 minus 0.4 t. And what I know is that as x approaches infinity, this is going to get really big. So I'm going to end up with 500 over 1 plus e to some very negative number. And 1 over e to a very negative is really going to give me 500 over 1 plus e to a negative number is 1 over e to a very positive number. But this is going to get closer to 0. So what I know is that the limit as x approaches infinity of this whole thing, by doing a little exploratory work, I know that's going to give me 500. That's a pretty big number. So when I go to set my window, my x min is going to be 0 to 50. My y min, well, I know I'm going to go as low as 9.9. Maybe I'm going to make that 0. But y max, I know I'm going to get very close to 500, so I'm going to make that 550. So, okay, so there's my graph, which is kind of interesting. And what I did was I found a horizontal asymptote. If you remember, this is what we do to find a horizontal asymptote. A horizontal asymptote is always found by taking the limit as x approaches infinity, or x approaches negative infinity. And now we've done some of this. P of 0 is 9.9, which is the initial wolf population. To find, okay, the limit as p goes to infinity, we know is 500. We're looking for p prime of 5. So what I'm going to do is take a small interval, maybe 5 to 5.0001. So let's test this. Y vars function y sub 1 at 5.001. Let's put another 0 in there. Minus vars, y vars function y sub 1 at 5 divided by 0.0001 gives me 22.636. 22.636, and this is a rate of change. So this is wolves. T is in years, so this is wolves per year, the rate at which the wolf population is growing. Approximate when the wolf population is growing most rapidly. Well, if we look at the graph, it looks like this is steepest at, let's see, I don't know, I'm going to say, eyeballing it, I don't know, maybe right around there. And so I'm going to say at t is equal to 10 years. And eyeballing this, the population was 267.79. Okay, good, good. I'll let you finish that.